Good afternoon, everybody, and welcome to NASA's Kennedy Space Center in Florida. We're here today for the pre-launch news conference for the Geostationary Operational Environmental Satellite R-Series, or GOES-R, whose launch is on target for Saturday, November 19th at 5:42 p.m. Eastern Time. Today, a launch readiness review was held, and I'll let the folks near me fill you in on all the details. We're very excited to be here. I'd like to introduce the members of the panel. To my left, Stephen Volz, Assistant Administrator for Satellite and Information Services for the National Oceanic and Atmospheric Administration, NOAA. Greg Mant, GOES-R System Program Director for NOAA. Sandra Smalley, Director for NASA's Joint Agency Satellite Division. Omar Baez, Launch Director here at NASA Kennedy Space Center. Scott Messer, Program Manager for NASA Missions from United Launch Alliance. And Clay Flynn, Launch Weather Officer from the 45th Weather Squadron at Cape Canaveral Air Force Station. Thank you all for being here. We'll begin with opening remarks, and then we'll be happy to take your questions after that. Steve?
Thank you, Mike, and good afternoon, everyone. So now we're just 2 days away from launching the first of NOAA's GOES-R satellites that will take our ability to produce accurate, life-saving weather forecasts to a much higher level throughout the United States and throughout the Western Hemisphere. GOES-R is a NOAA mission, which NOAA will operate the satellite, develop the science applications and services, and deliver those products and information to our primary user, NOAA's National Weather Service, and to users around the nation and, again, the Western Hemisphere. When it launches on Saturday, NOAA's GOES-R satellite, with its advanced technologies, will be a game changer for weather forecasting and climate science for many years to come. For decades now, NOAA satellites have been the backbone of our increasingly accurate and timely weather and climate forecasts. However, this new 4-satellite GOES-R series is really a quantum leap above any satellite NOAA has ever flown. Without a doubt, GOES-R will revolutionize weather forecasting as we know it. For weather forecasters, GOES-R will be similar to going from a black and white TV to super high definition TV. For the American public, that will mean faster, more accurate weather forecasts and warnings. That also will mean more lives saved and better environmental intelligence for state and local officials and all decision makers who need, for example, to make decisions about activities related to evacuations, for example, for an approaching hurricane should come our way. GOES-R's many exciting benefits will extend beyond the U.S. borders. Since the early 1970s, NOAA has maintained a full and open policy regarding its satellite data and information, and has provided real-time geostationary satellite imagery to countries and organizations throughout the Western Hemisphere. Our weather forecasting colleagues throughout Latin America, for example, will also have direct access to GOES-R data, which will help them issue faster, more accurate weather forecasts and warnings for heavy rains, as an example, that could trigger disastrous or destructive mudslides, monitor volcanic ash clouds, and other natural hazards that threaten life and safety. The GOES-R mission could not be possible without our partner NASA. NASA scientists and engineers have been working with NOAA for generations, and I mean that literally, because this program is more than 40 years old, on our critical weather mission, and this is just a continuation of that long-standing tradition now and into the future. NASA's Goddard Space Flight Center oversees the acquisition of the GOES-R series spacecraft and instruments, and it's a partnership of many other partners beyond NASA. Lockheed Martin is responsible for the design, creation, and testing of the satellites and for the space and spacecraft processing, along with 2 of the primary instruments, the geostationary lightning mapper and a solar UV imager. The Harris Corporation provides GOES-R's main instrument, the Advanced Baseline Imager, as well as the antenna system and the ground segment for processing and delivering the data. The Laboratory for Atmospheric and Space Physics in Colorado provided the Extreme Ultraviolet and X-ray Irradiance Sensor, another space weather instrument observing the sun. And the Assurance Technology Corporation provided the Space Environmental In Situ Suite, another space weather instrument of critical need. So on Saturday, we'll see not 10 years of hard work, but a generation of dedication and focus by the GOES-R community to coming to fruition when GOES-R launches into orbit. Thank you to the entire GOES-R team, and I look forward to a spectacular launch. Thank you. Mike?
Thank you, Steve. Greg?
Thanks, Mike. I'm honored to be here today to represent a fabulous team that has worked for over a decade to bring this mission to fruition. It's been an incredible team of NOAA and NASA working very, very closely together, as well as the contractors that Steve just mentioned, Lockheed, Harris, LASP, ATC. It's been a fabulous team working together on an incredible mission. In fact, I could say this is a historic mission for NOAA because we are bringing a level of technology into this mission that is really going to revolutionize weather forecasting. Just as a lead into some of our excitement, we have a little film I'll play in the background as I talk that represents the satellite landing here at Kennedy. So if I bore some of you, you can at least get excited about the satellite rolling in here. The satellite has a series of 6 new instruments. The primary instrument is our advanced baseline imager. This great imager is going to have 3 times as many channels as the existing system, 4 times the resolution, and 5 times the scan speed. And when you put all that together, it results in what Steve just mentioned. The forecaster's view of the Earth will be going from a black and white television type of view to HD TV. So what the forecaster will be able to see will be something like they've never seen before, and it'll have incredible applications to the warning and weather forecasting process. In addition to this advanced capability in the imager, we're introducing for the first time in operations a geostationary lightning mapper. So here we have an instrument that will be taking photos of the lightning fields of the Western Hemisphere about 200 times a second. And when you compare all those, you get a sense of where the severe weather is starting to really brew. So with this information, the Weather Service will be able to make a longer lead time forecast of severe weather and do it with much higher confidence, reducing false alarms. But in addition to these Earth-pointing platforms, we also have a lot of space weather instrumentation. We have a couple of telescopes in our ultraviolet imager that's imaging the surface of the sun. It's doing to the surface of the sun similar to what the Earth-pointing thing is doing to the surface of the Earth. We've also got an irradiance sensor, the EXIS, which is measuring the energy from the sun so that the forecasters and the space weather forecasters can help understand the impact of the solar activity on the Earth, whether it's communications, GPS signals, or whatever. We also have a couple of instruments, the SEIS and the magnetometer, that's measuring the near field around the Earth. The SEIS is measuring energetic particles, and the magnetometer is the magnetic field. All these combine to provide an incredible new capability for the nation. So we're all getting excited. This GOES-R is the first of 4 satellites, so we're buying 4 of these. This first one will be launched here coming up. And these 4 satellites will give continuity in the nation's geostationary weather satellite program through 2036. Thank you, Mike.
Okay, thank you, Greg. Sandra.
Thank you, and good afternoon, everybody. I have to tell you, I am thrilled to be part of this program and have the opportunity to be here with you today to talk about it, along with my fellow panelists, about this very important mission that's going to transform our weather forecasting capabilities. The launch of the GOES-R program, as Steve had shared, continues over 40 years of a NOAA-NASA partnership for the collaboration in the development of geostationary operational environmental satellites. The Joint Agency Satellite Division within NASA's Science Mission Directorate plays an important role in our partnership with NOAA. We serve as an acquisition arm for NOAA, where we bring to bear NASA's scientific and engineering expertise in the development of space flight and ground systems to support our partner organizations. Specifically for GOES-R, we support the development of the spacecraft, we launch it, we commission it, and then we end up transitioning it to NOAA for operations. It continues to be a pleasure working with NOAA to deliver this nationally critical weather system. The partnership began, as I mentioned, 40 years ago, beginning with the GOES satellite GOES-1 on October 16, 1975. And now, 41 years later, here we are, ready to launch GOES-R, and as you've already heard, it really is going to be revolutionizing how we are able to predict weather. At this time, I also would like to recognize the importance of our partners in this endeavor. Steve already mentioned Goddard and the Launch Services Program, as well as Lockheed Martin for the development of the spacecraft, the GLM and SUVI and magnetometer instruments, the Harris Corporation for development of the ABI and the ground system, the Laboratory for Atmospheric and Space Physics for developing EXIS, and the Assurance Technology Corporation for developing SICE. Thank you for your team's hard work and dedication in delivering this amazing next-generation geostationary satellite and ground system that will serve to provide weather forecasters the information they need to protect the public and the nation. Go, GOES-R. Back to you, Mike.
Thank you, Sandra. Omar.
Thank you, and thank you for attending today's brief. I am again fortunate to be representing the men and women from NASA's Launch Services Program here at Kennedy Space Center, and our partners, United Launch Alliance, our customer NOAA, and Goddard Space Flight Center, and their provider, Lockheed Martin. These folks have been dedicated to analyzing, fabricating, and assembling and preparing the Atlas V and the GOES-R spacecraft set for launch this Saturday. This will be the 67th flight of the Atlas V vehicle and the 4th flight of the 541 configuration. Rather than bore you with those details, let's roll a video of all those pieces coming together. That's the Atlas, or the Centaur stage. You're not going to see the booster because the center was closed when that came in, and we weren't able to videotape that. We had Hurricane Matthew pass by our coast here and made things difficult for us. But there it is. That's the Atlas V booster with the RD-180 motors that provide 861 pounds of thrust. Shortly you'll see how the solid rocket boosters are attached to it. We're using 4 of them. They each provide about over 300,000 pounds of thrust, making it to 2 million pounds of thrust in the end. Here you're seeing something a little different. Usually we just put up the Centaur and the interstage and Centaur forward adapter in different stages. There you saw it stacked. We now call that the OVI. And that is the GOES-R satellite within its 5-meter fairing. It did, this Hurricane Matthew that did come through here did slow us down a bit. It took us out by about 10 to 12 days, and we had some issues between the West Coast and here that we had to resolve that accounted for losing about 2 weeks of schedule on this mission. But this Monday we did our mission dress rehearsal. On Tuesday we completed our flight readiness review. We completed our launch readiness review this morning, and we plan to roll the vehicle out of the vertical integration facility tomorrow at about 9:30 in the morning. Then we'll load kerosene on board, and just before 11 o'clock on Saturday morning, the Atlas team will power up the vehicle, do their flight control checks. Our management team will be in place around 1 o'clock in the afternoon for a call to stations. And at about 2:07 in the afternoon, we will have our first hold at 15 minutes. The conclusion of that hold will poll the team for concurrence to proceed into the cryogenic tanking. That process will take approximately 2 hours. At 5:29, I will poll the team for concurrence to enter terminal count. Again, we enter another 15-minute hold. And we're set to launch at T0 of 5:42 in the afternoon. And with that, I'll turn it back over to Mike.
Okay, thank you, Omar. Scott?
Yeah, thanks, Mike. On behalf of United Launch Alliance, I want to welcome you to the GOES-R launch. We are super excited to be here and prepare to launch this critical satellite for NASA again. This will be the 11th launch for ULA in 2016 and the 113th consecutive successful launch since the company was formed in 2006. This is the fourth, as Omar said, the fourth launch of our 541 configuration. You can see the small model here to my right. You can see the 4 solid boosters here and the 5-meter fairing. It's powered by an RD Amros RD-180, and the second stage engine is an Aerojet Rocketdyne RL-10C. So I did give you several numbers, 113 consecutive successful launches. Those are important to you because it helps you to know that NASA has chosen one of the most reliable launch vehicles in the world to go put this GOES-R spacecraft up into orbit. And in fact, I did a little history looking, and ULA and our parent vehicles have launched every GOES satellite in the last 30 years successfully for the GOES program. So we have a rich history of working with NASA and NOAA and the GOES program, and we are super excited to be back here again doing that for GOES-R. We do have a video that will show you a sequence of events for the mission that you should expect to see on Saturday evening. So let's roll that video now.
The following profile details the important events of this mission using approximate times.
5, 4, 3, 2, we have ignition and liftoff.
The Atlas V RD-180 main engine and 4 solid rocket boosters ignite to generate the 2.25 million pounds of thrust to lift the rocket away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 35 seconds. At 46 seconds, the vehicle experiences maximum dynamic pressure. The first 2 solid rocket boosters, or SRBs, are jettisoned at 1 minute 50 seconds, followed a second and a half later by the third and fourth SRBs. The payload fairing is jettisoned at 3.5 minutes. As it approaches booster engine cutoff, the Atlas V is burning propellant at the rate of 1,856 pounds per second, traveling at over 12,440 miles per hour, and located 92 miles in altitude and 276 miles downrange. Booster engine cutoff occurs 4 minutes, 21 seconds after liftoff. 6 seconds later, the booster stage is jettisoned. The vehicle now weighs a little more than 5% of what it did at liftoff 4.5 minutes earlier. The first Centaur main engine start takes place 10 seconds after booster separation. Cutoff of the Centaur main engine occurs just over 12 minutes after launch. The mission now enters a nearly 10-minute coast phase. At 22 minutes, the Centaur main engine is restarted. This burn will last 5.5 minutes. Following the second Centaur main engine cutoff at 27 minutes 35 seconds, the mission now enters a 3-hour coast phase. At 3 hours 27.5 minutes after liftoff, the Centaur is started for a third and final burn. A minute and a half later, final cutoff of the Centaur main engine occurs. At just under 3 hours 32 minutes, Centaur releases the GOES-R satellite for NOAA and NASA.
Thank you. So ULA and the ULA team is proud to deliver the GOES satellite to orbit and to contribute to the increase in improvement in weather predictions that you've heard about. It's interesting to me, you know, the rocket business is a technologically challenging business, as you all know and we've seen. And in fact, precise weather predictions are critical for our launch campaigns. And in fact, I learned last night that 50% of all launch scrubs are caused as a result of weather. So it's a big boost to us as well as the public safety in order to have the GOES mission up there and to get this improved ability for weather predictions. As America's ride to space, ULA is committed to continue to deliver reliable satellites and payloads for NASA. And we want to conclude by just saying thank you to all of our partners. The entire ULA team is excited to be part of the GOES program, and we look forward to a successful launch tomorrow evening. Thank you, and back to you, Mike.
Okay, Scott, thank you. It sounds like you made the perfect introduction for Clay. Clay?
Thank you very much, Mike. The weather is favorable for the balance of this week's pre-launch processing activities, as well as the count on Saturday. If I could have a satellite picture brought up, I'd appreciate it. If you'll look at the satellite picture there, you'll note that we have near clear skies over the southeast United States. We're under high pressure with favorable weather conditions. High pressure will persist until tomorrow and into the count on Saturday. So expecting very good conditions. If you look out in the Midwest, you can see some clouds that are associated with the next system that'll drag a relatively weak cold front through central Florida Saturday evening. It should approach us in the panhandle of Florida Saturday morning. But nevertheless, we'll still be prefrontal through the count with relatively dry conditions and not expecting significant weather associated with that front as it approaches us during the evening hours. So I believe we should have pretty good weather conditions for Friday when we roll to the pad, as well as on Saturday during the count. So for tomorrow, for our MOP roll to the pad, we'd be looking for relatively light winds during the roll. We should have northeast winds. With the northeast winds, we'll have a few clouds coming in off the water, not expecting any rain and certainly no lightning. So favorable weather tomorrow. As I mentioned, light winds should be gusting in the low teens tomorrow morning, well below the roll constraint. So really don't see weather as any concern at all for any activities tomorrow. Once we get on console on Saturday for the count, with that frontal boundary that I mentioned coming into the panhandle of Florida, Saturday morning we'll watch our winds go more northerly and then northwesterly as that front encroaches or approaches central Florida. But nevertheless, the pressure gradient remains relatively light, so we would be looking for winds in the mid to upper teens during the count at a couple hundred feet, and really just about 15 knots or so during the window. So favorable conditions. The front, as I mentioned, comes through Saturday evening, late Saturday evening, and during the overnight hours, and that would increase our pressure gradient, but we should beat that on Saturday afternoon. So if I can have the graphic for the forecast for Saturday for the count. What we'd be looking for is just scattered skies at about 3,500 feet, maybe some thin cirrus about 26,000 feet, good visibility, 7 statute miles. Our winds out of the north-northwest from about 330 degrees at 10 knots gusting to 15. With a 10% chance of violation, that's a very low likelihood of any type of cumulus cloud rule violation. We have good substance for sinking air over us. It'll cap the vertical development of the cumulus cloud. So should have very favorable conditions on the count on Saturday. And for a 24-hour delay, as I mentioned, that frontal boundary come through late Saturday evening, and during the overnight hours, the pressure gradient tightens up. We get cooler air behind that front. So we'd be gusting in the mid to upper 20s at a couple hundred feet during the overnight hours. But as we get into the afternoon hours, should we be on the pad for an attempt on Sunday, we should watch those winds come down, and we'd be looking for winds gusting to about 20 knots or so at a couple hundred feet by the time we get to the window. Again, that's well below the liftoff constraint. So really we should be in pretty good shape Sunday as well. So we'd be looking for just scattered skies about 3,500 feet, good visibility, a little bit of breezer, as I mentioned, gusts to about 20 knots with a 20% chance of violation. And again, the principal concern there would be cumulus clouds. So that's all I have. Pending any questions, Mike, I'll turn it back to you.
All right, thank you. All right, we're ready for questions. And first off, I would like to remind you, if you're in the room, to wait for the microphone, state your name and affiliation, and to whom you're addressing your question. We have a phone bridge for those who are interested in calling in. And one thing, if you're following on social media, our NASA social media manager, John Yembrick, is here. He's tuned into the hashtag AskGoes. So if you have any questions and would like to convey them that way, please go ahead and do so, and we will be happy to start off with questions in the room. And Marcia Dunn.
Marcia Dunn, Associated Press, for either of the two NOAA gentlemen. I was hoping to get a cost on this satellite, and if this satellite had been up there for Hurricane Matthew, do you think you could have, there would have been better tracking and knowing that it would stay off the coast here? Or I'm just wondering how much improved would you have been able to follow that hurricane in particular?
Sure, let me start off. The cost, when we put big programs like this together, obviously there's a lot of development and implementation costs. So we sort of started off in the mid-2000s estimating its life cycle. So at that point, we estimated about $11 billion life cycle, which is buying 4 satellites, putting the entire ground system in place, and operating it for 20 years. So there's a lot of cats and dogs in that cost estimate. Is that usually people are interested in like the cost of what's riding right there. And so, and so the way I think it's best looked at is if I had to go buy a replacement one, so if I went to all of my vendors and said, bring it back, that'd be about $500 million to replace the payload as we see it. So I'd like that. That's sort of a nominal cost of the
500 million.
500 million, yeah.
And on the modeling side of the house then, so what would GOES-R do now if we'd had it when Hurricane Matthew was rolling through? First, it's important to remember that the satellite is a piece of a larger observing system. So the satellite is combined with ground observations, with modeling, and with other expertise that from our weather service and from others that pull together. What GOES-R then adds to that is in its high resolution and its high repeat rate, it really brings a different, an acceleration to the knowledge of what's happening, particularly in the case of intensification of a storm. So you can see when it might move from a Category 2 to a Category 3 and 4, which right now might take a couple of hours between image suites to see, we'll be able to see in minutes as that intensification occurs. So for a steady a storm that just moves normally, it won't be an obvious difference. But for something where you're looking for dynamic changes, the GOES-R capabilities will really enhance that ability. The second is the higher resolution will allow a much greater visualization of the eye wall and of the scattering of storms around the perimeter, so you'll be able to have more local observations of what might be happening on pieces as you look at the storm in different areas and different pieces. So as a part of the overall system, it'll take us a while to integrate the GOES-R capabilities into our observing system, and I think we'll still be seeing advances that we can't even anticipate right now as we do that over the next years and decades as we add GOES-R and S and T and U to the system. But those are the immediate ones we would see, both in the higher temporal resolution, so we see intensification when it occurs, and higher spatial resolution, so we can be more discriminating in what's happening in different regions in what might be a 500-kilometer wide hurricane.
James, did you have a question?
James Dean, Florida Today. I mean, really just following up on that idea, I'm just curious if, I'm not a forecaster, will I notice the difference? And, still specifically with Matthew, I mean, can we say with certainty that we would have had a better model, we would have likely known where it really was going to end up rather than where we thought it was going to be, and how that would affect evacuations and so forth?
So I think it's fair to say, and it's that the improvements of GOES-R will improve our ability to do those tracking and forecasting. To say exactly whether it would be a 10% or a 50% increase in the resolution of a particular landfall is difficult to project specifically. But yes, you would have an improvement over time with the strength of the hurricane and the landfall probabilities. As we've seen over the last 30 years, as our projections on the landfall have narrowed down, as we have much better accuracy now than we did 20 years ago and 10 years ago, that's partially ownership capability, but it's also our modeling and our understanding. And that's what GOES-R will bring, an entire new spectrum of frequencies, of bands, of different visualizations that will improve our modeling over time. So it will be an improvement in those parameters that you mentioned. As far as what the forecaster will use, was mentioned earlier today, instead of waiting 3 hours for an imagery update, you'll be seeing it in near real time. You'll see image updates every minute or every couple of minutes with about a 5-minute latency. So there won't be a 3-hour wait for the next image of the full disk of the Earth. It will be minutes away. So you will see on a regular basis, within minutes, the increased resolution, the new imagery as the storm is changing and moving over time. So that and is direct broadcast to everybody in the United States, and particularly to the regions that are experiencing severe storms. We'll be looking, I'm sure, be waiting for that and watching that in near real time.
Ken.
Hi, Ken Kramer, Universe Today and the Northeast Astronomy Forum. I got 2 quick questions for NASA NOAA people. One is, you talked a little bit about the ground systems, and following up on what you just said, how have you improved those ground systems, and how will that help get this vastly increased data out to the weather forecasters more quickly? And the other question is, talk about the benefits of the partnership between NASA and NOAA as opposed to just NASA doing this or just NOAA doing this. Thanks.
I'll start with the first one. The investment in the ground system was really driven by the amount of data that's coming down from this mission. About 30 megabits a second was pouring down, and we're creating products on the fly continuously. And so you can never get behind or the data will just stack up. So we're processing, putting products and getting to the Weather Service on that kind of cycle, just immediately pass through these data. So very perishable stuff like the lightning data is getting to the Weather Service forecaster within seconds. I had a forecaster, we ran simulated data runs of all this to many weather forecast offices, and the best way I've heard one of the forecasters says, Greg, in the past when you've delivered the GOES satellite data, you've been showing me loops of what has happened. You are now providing me a movie of what's going on right now. So in a sense, that latency is so short that this data is getting to their hands immediately, and their excitement about how they can use it in real-time forecasting is really increasing. So there's a lot of, my friend down at the end here will be very excited to use these data sets in his everyday forecasting.
So on the NASA NOAA, and I'll start and then I'll ask Sandra to pick it up. When I look at the NASA NOAA partnership, I would characterize it in the way that there's breadth and depth. On the breadth side, NOAA has the breadth of the global mission, the weather mission, and we have the access to and connections to the weather forecasters, the weather forecast offices, the users on a national scale. And we have the modeling and the capabilities to interpret the data from multiple sources, not just satellites, but others, as ground radars, radiosondes, balloons, et cetera, to integrate that into a forecasting model and capability, and the ability to foresee what would be the next big step we would need to improve that capability. What NASA brings is the depth. NASA has the technical and the scientific, the technical and engineering expertise to figure out how to turn that envisioned future observing system into a reality working with NOAA. So it really is a good mesh of we have the user requirements, we have the mission ownership. NASA has the capability and they have to take that and to make it a reality working with us on a day-to-day basis. And I'll turn it over to Sandra if she wants to add.
Sure, yeah, I'll just add, I think the partnership is multifaceted. So in addition to what Steve said, there's the whole concept of research to operations. So, NASA is focused on advancing research, advancing our technologies, understanding, the intricacies of how, in this case, how weather operates on Earth, the interactions between the ocean, the Earth, the atmosphere, et cetera, the sun. And so we develop our understanding or advance our understanding of those critical interactions and partner with NOAA to actually utilize it in an operational mode to support the weather forecasting. And I would say that this partnership, the scientists in both organizations and really around the world use data from both the research satellites that NASA builds as well as the weather satellites that NOAA builds. And there's even a partnership in terms of at times sharing platforms. So for example, there's we're planning to fly RBI on the JPSS mission. So it's a case where, both in the past and in the future, sometimes we share instrumentation on common platforms, depending on whether it's a NASA platform or a NOAA platform.
Okay, we'll take a question over here.
Thank you. Sawyer Rosenstein with Talking Space. This is for anybody involved with the launch processing. I know obviously Matthew caused a bunch of the delays, but so did a problem with, I believe it was the Common Core booster. I was wondering if you could go into a little bit more detail on what you guys actually did, or what problem was and what you guys did with this vehicle, and if it was the same thing that you did with the 401 that recently launched out of Vandenberg. Thanks.
So I'll go ahead and take that. So we have worked a couple of different small issues throughout the launch campaign. That's not uncommon. We have a very aggressive approach to prepare the vehicle to make sure we get to that 113th consecutive successful launch. So we had a couple of issues with a valve. We've worked an issue with a battery on the Centaur, and just a couple of minor things that we've done to make sure that we've got the best chance of being successful for the GOES mission. I wouldn't say that it's similar to what we did on OSIRIS-REx. Everyone seems to have its own separate little things that we have to deal with, but we've definitely taken a very conservative approach. We've worked it hard, and we're very confident that the launch on Saturday will be successful.
I was also wondering if that was related to the one last week out of Vandenberg.
So we did have a couple of issues that were similar to the WorldView 4 launch, which we had on Friday of last week. And so we worked those simultaneously. At one point we had a charter airplane in the air picking up new parts for both vehicles and going coast to coast to make sure that both vehicles were ready to go.
Okay, John Yembrick has been monitoring the hashtag AskGoes and has a couple of questions.
Yeah, there's quite a few good questions here, actually. One is, will there be any additional evolutionary changes to each GOES satellite in the series, or will basic instrument suites remain the same?
Yeah, we are building 4 identical spacecraft. That's one of the ways you keep the cost under control is you build that. So we will provide the same capability over the next 20 years.
The series was 2036, you said, the lifespan of the series, but what specifically this satellite itself, what is the expectation lifespan?
We expect each satellite to last about 10 years of operations, so they have enough fuel to last about 18, but the design was for about 10. So for 4 of them, that's 2, then you use 2 simultaneously in east and west. So 2 in the east and 2 in the west is what adds up to 20 years.
Thanks, and last question. For Greg, when do you expect the first images to come down?
We expect the first ABI images for about 2 months in, and we'll be having a great press release on it'll be like your baby picture, right? Yeah. First image of the ABI, so we'll let you all know when that's coming. Subsequent instruments will be a little bit longer. About 3 months in, we'll see the raw data start to flow, so the weather forecast will start to see the first flow of data about halfway through our test period. So.
I'd like to follow up on that first question about the stability of the GOES-R platform. As Greg mentioned, is we built 4 at once, and that was for very consciously to make sure we retired the risk of building complex new instruments, and we built a bunch of them so that we have a consistent, reliable data set. But to take off of what Sandra Smalley had said a moment ago too, these are a piece of a larger system. NASA flies other measurements. The other nations fly other measurements in orbit, geostationary and low Earth orbit. So the GOES-R platform is a basic, very high-performing baseline, but we augment that with observations that we introduce over the period of that life cycle. So even though the GOES-R will be a flat performance over the next 20, consistent performance over the next 20 years, we will be consistently adding and mixing different measurements to increase the capability of the overall observing system as we do that.
Okay, we have a question here behind John.
Hi, Michael Phillips with Weatherboy Weather. My question is for the NOAA gentleman. In the extremely unlikely event there's an anomaly, either with the launch or the deployment, how vulnerable is the U.S. To coverage from the existing GOES satellite? If there is a failure with this one, can the 3rd generation be sustained while we wait for the next GOES to be launched, I guess in 2018?
Are you the gentleman or am I the gentleman?
Nobody's ever called me a gentleman before, so.
I'll take that one. As Greg mentioned a moment ago, we have a constellation in orbit now. It's 3 satellites in orbit. We have one called GOES East and GOES West, one over each side of the continental U.S. Together, they provide observations 24/7. And we have a 3rd, is our GOES Spare, which sits in the middle so it can pivot to either direction if we have a problem. Those 3 satellites are of different ages. They're fully meeting all observing requirements. Some of them are showing signs of age. But all of them are fully functioning. Our observing system is fully capable today, and we expect to be capable a month from now. If, in the event of an anomaly, which we don't expect, based on what Scott mentioned, the capability and the focus we did on making sure we have a good system, those satellites will continue to operate, and we expect to provide the continued service that we have. GOES S is the 2nd of this 4-satellite series, is now targeting a spring of 2018 launch. And actually, I just heard from Tim Gasparini from Lockheed, just went through its environmental acoustics test yesterday. So it is an assembled spacecraft and system going through its environmental testing now and is well on the road to be launched in about 18 months, or a little less, about 16 months, I guess. So we have a system in orbit right now with 3 satellites. We expect those to continue to provide capable service for the foreseeable future. And in the event of a really, really bad day, we have another satellite, GOES S, coming along right behind us, and we will expect to continue to perform as expected for the nation.
Question in the back of the room.
Hi, Dave Jones with Storm Center Communications. This is questions for Greg. Greg, I know that GOES-R satellite doesn't happen overnight, and it took a lot of time and effort to put together the whole program. I was just wondering if you could give us a quick little description of when the vision for GOES-R started and how you got the Weather Service and these other organizations to get ready to accept the GOES-R data once it gets up and operating.
Okay, Dave. The formulation, the ideas come out in the formulation stages where you have contractors and the government start thinking, well, what do we have today? What the scientists are saying, what could be? Those kind of ideas were floating around actually in the late 90s. Then in the early 2000s, you start formulating, well, I could do this, we could do it with multiple different satellites. You start coming up with ideas. Our first development production contract was let in 2004 for the Imager. So that tells you, that was the first hardware contract. So subsequent to that, by 2008, we had the rest of the systems under contract. But that's for us engineers, that's the easy part. the working with the user community is is equally challenging because they're very much focused on today and forecasting that. And so what we had to do is we put a number of scientists out into the Weather Service to start engaging them on what the future looked like, to start engaging them on what these data sets will start looking like, start engaging them on what they could possibly do differently and better. And so we started that about 6 years ago. We started flowing data sets. We actually simulated the GOES-R data by running models of the atmosphere, sampling like GOES sample, take those samples and running it through our processing system to create products just like GOES, and then streaming those products out into the Weather Service offices to start getting feedback from them and to start to get them used to the tempo and what high tempo resolution imagery would do for them, or what lightning data do for them. And over about 3 years, the excitement started to build. And so we have gotten really good engagement across the Weather Service over those years, where the enthusiasm is bigger than anything I've seen in terms of what's coming down the stream. When we first started doing this, they gave me sort of a cocked-eye look saying, well, yeah, everybody promises stuff, Greg. And after about 3 years of working with them, the feedback we started to get was, this is wonderful, I want in my office yesterday. So it's an example of how much work it takes to get the weather community used to new data sets and familiar with that. But the fact that we put all this work in for all these years means once we get the data turned on from this satellite, we're going to have a very engaged user community ready to use it from day one. So we're very excited about the success in working with users on that.
Hi, Matt Safino, KGW TV, and I guess this would be for Greg or Steve. What factors and pressure go into determining if GOES-R will become GOES-West or GOES-East, and when do you think that decision would be made?
Okay, good question, because this is a big change from existing capabilities. So we will look at several factors. One is the health of the constellation. I mentioned earlier we have 3 satellites in orbit. They have different ages and different performances on orbit. So we'll make a decision partially based on which constellation element is the most in need of replacement. Second is the checkout of GOES-R itself. We've mentioned what we expect it to be able to do. We have examples from from the Japanese of flying a similar instrument. So we have an idea, but we'll take the first 6 months to go through and really look at the performance and how well it integrates with our weather models, with our forecasters, to get a feedback on how we're utilizing it, how well we're utilizing it. And at that point, about L plus 6 months, launch plus 6 months, we'll make a determination whether it should go to East or West, with the location time to be about launch plus 1 year. So about this time next year, GOES-R will become it'll become GOES-16 sooner. It'll become GOES-East or GOES-West as we go through that. And as I fully expect, there'll be a lot of interest in getting it to one or to getting to both, which will be a challenge, of course, to go to both. So this will be not something that happens behind closed doors. There'll be a lot of interest, a lot of public discussion, I'm sure, from all the user communities. But about a year from now, it'll be located. About 6 months from now is our target to say where it's going to be headed.
Okay, we have a question further in the back.
Hi, I'm Mike Augustinak with CBS in Minneapolis. Kind of piggybacking off of Dave's question, we know when this new technology was starting to be developed, but remind us, how old is the technology that we're dealing with on the current GOES platform? When was that sort of being worked on?
The current GOES, the instruments on the current GOES were actually first done on GOES-I, so that was mid-'80s. So that design was really, late 70s, early 80s. And so this, and actually what we just did with those instruments, before GOES-I were spin-stabilized spacecraft. So he had a little bit different technology for the instruments, but you really took about the same from a channel perspective and just made it off of a 3-axis stabilized spacecraft. So it wasn't really dramatic from a user, a big jump at that point. So I really look back and said, since the start of the GOES program, there's been a couple of channels added, for example, to the imager, but this is a quantum leap that we haven't seen since the introduction of the geostationary program in the 70s.
Okay, we're going to take a question from the phone bridge, then we'll come back in the room with a question from Rick, and then we'll go over across the room here. I believe that we have Mark Gotch on the phone. Mark?
Yes, good afternoon. Thank you for your informative briefing. The thing of it is, we have learned, due to NASA's dedicated research, that our planet's population will be more vulnerable to extreme weather events, tornadoes, hurricanes, etc. in our future. We thank you for your dedication to this mission and what it will do to the future of forecasting. GOES-R is ready to go. We look forward to your mission success. Can you tell me, based on the future going forward, you launching 4 GOES-R satellites in the future, what will determine the spacing of those GOES-R satellites being launched? And will there be advancements, I would expect, in technologies going forward? You had mentioned they were built the same currently. Will there be changes to them at the times they are going to be launched?
Actually, Steve mentioned that GOES-S is already built and in testing. The instruments are basically built. We have 4 of our imagers completed, and Harris has finished all 4 of them. The 4 axes are finished. So in a sense, the capability is all being built in one fell swoop. And again, to reemphasize what Steve said, this is just one piece of the overall operational observational constellation. So other improvements can be done in other platforms and other capabilities that blend with it to make it a complete observing system.
Let me add a point to that as well. Greg, to what Greg just said is all true and important. But remember the contribution of GOES-R, this 40-year leap, as mentioned in the previous question, in terms of technology and capabilities, is being added to an existing system. When you introduce that level of significant enhancement, that quantum leap forward, it makes everybody else smarter too. It makes all the other pieces of that observing system more capable. So now with GOES-R's high resolution, high repeat rate, and a number of channels, it is comparable to our low Earth orbiters that also provide, with less temporal frequency, a very high resolution image of the Earth. We fully expect that in time, as we learn GOES-R and we learn how to process the data of that plus our low Earth orbit satellites, we will find abilities and products and information sources from the combination of the different elements of the satellite, which will continue to grow over time. So even though we know right now what we expect GOES-R to do, we design the instruments, we know what it's capable of, we don't yet know what the system is capable of when we bring all these different elements together. So to put it differently, we know what GOES-R does, but we don't know what we can do with what GOES-R does yet. And that's going to evolve and increase over time, and it's going to be continually increasing as we add other instruments into the mix. So even though a piece is static, the system continuously improves as we integrate all the different elements together. And that's going to be a characteristic of this system for the next generation as well.
Okay, we have time for 2, possibly 3 more questions. Rick?
Yes, this is a question of Rick Lansby with WFIT. I guess this is a question for Sandra. Could you compare the overall capabilities of the GOES-R with the Cygnus mission, which will be launched here next month from the Cape?
So I am probably not the best person to answer that question, but I'm happy to get back to you on that one.
Okay, we have a question in the second row.
Thank you. My name is Erica Groh. I'm a meteorologist from WNBC. I had the opportunity to participate in the Hazardous Weather Testbed Experimental Warning Program back in 2014 in Norman. So I got to fiddle around with some of the, pseudo instrumentation that we're going to be getting access to in the near future. What I'm curious about, because there's been a lot of talk about how this is going to improve nowcasting. What about, as people talked about just in front of me here, What about the hurricanes? What about the mid-latitude cyclones? What about the hazardous weather events that involve snowfall, things that are more day-to-day even? How is GOES-R going to make our forecast better? Is this data going to be better because of the resolution, or because we have 3 times as many channels on the infrared, or is it a combination of those? Is this data all going into the GFS model? Like, how is it going to benefit us directly as operational forecasters?
Yeah, you will have a chance with our scientists in a little bit on their press conference, so you can ask that one again. I would say that, we extrapolate from what we use GOES today, which is heavily in the warning program. So we've really worked with the Weather Service on how to do that. Once we get the data streams flowing, we have done some work with the modeling community, primarily with the rapid update models that really can take advantage of the temporal refresh capability of GOES. But until we get that data stream really flowing and fine-tuning it, that we'll start to see where those benefits will really play out. So again, where GOES is big impact today is in the warning program. We do see a lot of impact in the modeling program, but as you know, the modeling and the data assimilation is quite a significant science. And while we've started that work, when the data flows, I think we'll start seeing some major growth and impact with these data sets in the models.
Thanks, Greg. Unfortunately, we are out of time for this briefing, but as Greg mentioned, we do have a mission science briefing for GOES-R up and coming, and that one will be on NASA Television's media channel, and we invite you to stay tuned for that. Thank you very much.